Good day, everyone. Our topic for today is all about Spearman's rank correlation coefficient part 2, which is all about hypothesis testing using Spearman's law. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel. Just select the playlist section. And now, let's proceed to our main topic for today, which is all about Spearman's rank correlation coefficient. When the entries in a set of data are ranked, the Spearman's rank correlation coefficient, also known as the Spearman law, will be used in the hypothesis testing. The formula to solve the Spearman law is ρ equals 1 minus 6 summation of d squared over n quantity n squared minus 1, while the formula to solve the test statistics of the Spearman law is equal to ρ equals square root of n minus 2 over 1 minus rho squared, where n is the number of pairs, d is the difference between two sets of ranks. To interpret the person R or the Spearman law, we have the following values. For the 0.00, the interpretation is no correlation. 0.01 to 0.019 or negative 0.19 to negative 0.01 is very weak positive or negative correlation. If your answer is negative, the interpretation is very weak negative correlation. If your answer is positive, the answer is very weak, or the interpretation is very weak positive correlation. If your answer is 0.20 to 0.39 or the negative of these numbers, we have weak positive or negative correlation, and so on. If your answer is 1.00, the interpretation is perfect correlation. If your answer is more than 1.00, then there is something wrong with your answer because in person R or in Spearman law, it is very impossible to get higher than 1.00. Now, we have the following steps in doing hypothesis testing in Spearman law. Step 1. Determine the null hypothesis, the alternative hypothesis, and the computation. Step 2. Solve for the Spearman law. Step 3. Solve for the t-test of the Spearman law. Step 4. Get the degree of freedom, alpha, and the critical value. Step 5. The decision. And Step 6. The conclusion. Example number 1. 10 instructors were rated by 3rd and 4th year students on their mastery of the subject matter, and the results were tabulated. What is the Spearman law value of the data? So, we will solve it at 5% level of significance. And the imperative is determine if there is a significant difference. I think this is wrong. It should not be significant difference. It should be if there is a significant relationship in the scores obtained by the teachers or significant correlation. HO or the null hypothesis. There is no relationship in the scores obtained by the teachers. HA, alternative hypothesis. There is a relationship in the scores obtained by the teachers. Now, these are the scores of these 10 instructors. Okay, so these are given. Okay, now for the first column, R sub x, mean to say we will rank the values of x, the third year, scores to their 10 instructors. So 44 is rank 4, 45 is rank 3, 38 rank 6, 32 rank 9, 46 rank 2, 47 rank 1, 37 rank 7, 35 rank 8, 27 rank 10, and 40 rank 5. We will rank this score from highest to lowest. For RY, we have 46, 3.5, 43, 6, 47, 30, 10, 39, 8, 37, 9, 44, 5, 46, 3.5, and 48, 2, and last 51. The highest score is 50, and the lowest is 30. There is a tie between instructor 1 and instructor number 8. They both got 46 for the 4th year students. For the D, we will get the difference. 4 minus 3.5 is 0.5. 3 minus 6 is negative 3, negative 1, negative 1, negative 6, negative 8, 2, 4.5, 8, and 4. For the D squared, we will get the squared of D, meaning to say multiply by itself. 0.5 times 0.5 is 0.25. Negative 3 times negative 3 is positive 9. 1, 1, positive 36, 64, 4, 20.25, 64, and 16. Finally, get the total of d squared, and that is what we call the summation of d squared, which is equal to 215.5. We're done with the table. Now, let's compute for the Spearman law. To compute for the Spearman law, we have the given n equals 10 instructor. Summation of d squared is 215.5. The formula is rho equals 1 minus 6 summation of d squared over n quantity n squared minus 1. Just substitute the given to the given formula. So we have 6 quantity 215.5 over 10 quantity 10 squared minus 1. 6 times 215.5 is 1,293. 10 squared minus 1 is 99. Multiply 10 times 99, you have 990. Divide 1,293 and 990, the answer is 1.31. Subtract your answer from 1. So 1 minus 1.31 and you will get negative 0.31. Going back to the interpretation for negative 0.31 is weak negative correlation. Why negative? Because our answer is negative 0.31. Now, for the t, test statistics, we have the formula. T equals rho square root of n minus 2 over 1 minus rho squared. Just put the given in the formula. Our computed rho is negative 0.31 and n is equal to 10. So we have this given. Now, 10 minus 2 is 8. Negative 0.31 squared is 0.10. Then copy the negative sign for this one. So we have negative, then just copy. Next, 8 divide 1 minus 0.10 and you will get 8.89. Get the square root and you will get 2.98. Always round off your answers to nearest hundredths. And multiply the 2 and you will get negative 0.92. That's our answer. Now, for the degree of freedom, we have a formula n minus 2. N is the total number of population. Our total number in our given is 10 instructor. So 10 minus 2 is 8 and the alpha is 0.5. Our critical value is positive negative 0.632. Now, how do we get positive negative 0.632? We have a table here. This is entitled Table of Critical Values for Persons R. So you may download it in Google. Now, our degree of freedom is 8. Our level of significance is 0.5. It is given in the problem. Now, we will use two-tailed because our two samples are two independent variables. So we have 0.05 and 8. The intersection of the two is 0.632 or positive negative 0.632. Therefore, the decision for this one is, since the computed value is equal to 0.92 is less than the critical value which is equal to 0.632. Thus, we will reject the null hypothesis and accept the alternative hypothesis. If it is within negative 0.632, then we will accept HO and reject HA. But unfortunately, our computed value is less than 0.632. Thus, the conclusion is there is a relationship in the scores obtained by the teachers. Another example, compute a Spearman's rank correlation coefficient for the following variables to determine the degree of association between the two variables. So here, the first the HO or the null is there's no relationship between the two variables, and HA is there is a relationship between the two variables. What are these two variables? So we have X and Y, and we have 11 persons or populations. So here are the values of X and Y. Now, for the ranks of X, we have 9, 1.5, 4, 6, 8, 11, 5, 1.5, 3, 7, and 10. For the ranks of Y, we have 10, 1, 5, 4, 6, 9, 7, 3, 2, 8, and 11. For the difference of R sub X and R sub Y, we have negative 1, 0.5, negative 1, 2, 2, 2, 2, 1.5, 1, negative 1, and negative 1. For the squared of the D, we have 1, 0.25, 1, 4, 4, 4, 2.25, 1, 1, and 1. Finally, get the total of this squared, and that is the summation of this squared, which is equal to 23.5. Now, solve for the Spearman law. We have 1 minus 6 summation of d squared over n quantity n squared minus 1. So just put the given, and 6 times 2, 23.5 is 141, over 11 squared minus 1 is 120. Multiply 10 times 120, you will get 1,200. Divide it from 141 and you will get 0.12. 1 minus 0.12 is 0.88. Now, looking to the interpretation in the table, and the answer is very strong positive correlation. Finally, we have the t. For the t, we have the computed raw of 0.88 and 11 for the number of n. 11 minus 2 is 9, and 0.88 squared is 0.77. Just copy the negative. And then, 9 divided by 1 minus 0.77, and you will get 39.13. Just round off your answer to the nearest hundreds. But if you are using a scientific calculator, you can continue computing it without rounding off. Now, get the square root of 39.13 and you will get 6.26. Multiply it to 0.8 and you will get 5.51. Alright, now our DF is n minus 2, 11 minus 2 is 9. And alpha is 0.05. Where did I get 0.05? If the problem doesn't have any level of significance, you may write 0.05. But it depends. If the problem is all about medicine, that's 0.01. If it is educational or something experimental that is not involved medicine, you may use 0.05 or 0.10. For the critical value, we have positive negative 0.602. So let's see if our critical value is correct. So our degree of freedom is 9 and we have 0.05. So the intersection of the two is 0.602. So we're correct. Now, since the computed value is 5.51 is greater than the critical value, which is 0.602, as you can see, I use the positive sign here for the positive negative 0.602 because our computed value is positive. Thus, reject HO and accept HA. Therefore, there is a relationship between the two variables. So that's all about the hypothesis testing using Spearman rank correlation coefficient. With that, thank you very much for listening and good day.